Okay, one last example that we didn't have time for in the last video. We're going to verify the trigonometric identity 1 over the cotangent of beta plus the tangent of beta equals the sine of beta times the cosine of beta. So in case you were wondering, that funny looking thing is the Greek letter beta. It's the Greek version of our letter B, and it's just in there for variety. Instead of an X or a theta, I decided to use beta, but that doesn't make a difference. So let's verify this trigonometric identity. Let's start with the left side, 1 over cotangent plus tangent. What can we do with that? If you were in class with me in person, I'd ask you to shout out a suggestion. So go ahead and shout out a suggestion, and I'll see if I can hear you through the screen. What's that you say? You say you want to replace cotangent with cosine over sine and replace tangent with sine over cosine. Okay, let's try that. Now we could add these two fractions together by getting a common denominator, but let's do it a little differently. Let's take care of this complex fractions within fractions, by multiplying the top and the bottom by whatever it's going to take to cancel out all these little denominators. So we need to be able to cancel out a sine of beta and a cosine of beta. So I'm going to multiply the numerator of the whole thing and the denominator of the whole thing both by sine of beta times cosine of beta. So on top we just have 1 times the sine of beta times the cosine of beta, and on the bottom we have what we had before, times the sine of beta times the cosine of beta. So what happens? Well, of course, on top, 1 times sine beta cosine beta is just sine beta cosine beta. On the bottom, when we distribute, multiply that through, we've got cosine beta over sine beta times sine beta cosine beta, but the sine over sine cancels out. Plus, we've got sine beta over cosine beta times sine beta times cosine beta, but this cosine over cosine cancels out. So what do we have left? Well, we got a cosine times a cosine here, plus we got a sine times a sine here. So that's sine beta cosine beta over cosine beta squared plus the sine of beta squared. See if you can guess what happens next. Hint, it involves this cosine squared plus sine squared. That Pythagorean identity said that that's equal to 1. So what we have here is sine beta cosine beta over 1, which is, of course, just sine beta cosine beta, which is what we were trying to end up with. So we did it. We verified this trigonometric identity. These two expressions always give you the same value for anything you plug in for beta, as long as it's not something that makes one of these undefined.